that you use to the metric system in lab, and then touch on some calculations in lecture as well. You'll touch on more calculations, especially if you go into the nursing program, yes? You'll be doing more math. It's coming in your future. All right? So get comfortable with your numbers. All right, chemical bonds. Why do things or are things attracted to each other? Opposites attract, yes? But what is the thing that all of these guys want in their future to be? They want to be stable. And what does stable mean in the eyes of an element or atom? Yeah, did we talk about this? Okay, but you guys know it already. You're wicked smart. That's good. Stability is a full outer shell. What is she talking about? What's a full outer shell? Well, I'm talking about this orbital where electrons run around a nucleus. And back to the periodic table, you can get a lot of information about what's going on in that outer shell by the way the periodic table is set up. Does anybody know what I'm talking about? Well, if you look, especially in the purple areas of your periodic table, you can see numbers on the top of those columns. Does anybody know what those numbers mean? Well, I'll let you know. Those numbers have to do with how many electrons are in the outer shells of the elements that are in those columns. So if I look at group 1A, how many electrons do you think is in the outer shell of those elements or atoms? 1. All right, let's stretch. How about group 2? 2. How about, skip over those guys in the middle because we're not going to talk about those right now. How about group 3? 3. How many outer electrons does carbon have? 4. What do they want? Remember the number 8. If I want to be stable, I want to have a full outer shell. And the number is 8. There's 2 exceptions to the rule, though. Anybody know who the exceptions are? Well, it just happens to be one of the guys we have up here. Hydrogen and helium. The reason is they only have one energy level because they don't really have many electrons. So in hydrogen, there's only one energy level. In helium, there's only one energy level. But again, they want that energy level to be full in order to be stable. All right? I'm going to ask you a question. It's either one or the other, the answer. Which one of these guys, hydrogen or helium, has a stable outer shell? Helium. Because in the first energy level, you can only fit 2 electrons. So that's why when you look at the periodic table, helium's hanging out in group 8. Because even though he doesn't have 8 electrons in his outer shell, he's still what? He's still stable because he only has what? He only has one energy level to fill. And those 2 electrons that he happens to have, how'd you know he had 2 electrons? Yeah, because it was up here on the board. But how do you know it from the periodic table? What number? The atomic number, which is right above the symbol, tells us, wait a minute, didn't she say it told us the number of protons something had? So what does that have to do with electrons? only here on this page, and only these elements, just these elements right here, only on this page, just right here. You getting the point? These are all neutral. Can we find them in different forms in nature? Absolutely. But just these guys right here, only on this page, are all neutral. And if I'm neutral, what does that mean about the charges I possess? Neutrons I'm not going to worry about because they're neutral, right? Yeah, you have the same number of protons as you do electrons. And if I tell you that helium has 2 protons, guess how many electrons it has? 2. If I tell you carbon has 6 protons, how many electrons does it have? 6. So that's another thing this tells us as well. So, if I'm hydrogen and I only have 1 over here on this side, then that's going to be in my first energy level. What do I need to be stable? I need another electron. Or what if I get rid of that? Will that make me stable? Yeah. How about helium? What's he need? Nothing. He's in a group called the noble gases. And these elements are not very active because they don't really need anything to be happy. They're all set the way they are. We call these guys, does anybody know what the fancy term is for something that's not very chemically reactive? Inert. Very good. So the noble gases, which is group 8 on this chart, and helium just happens to hang with those guys even though he only has 2 electrons, are inert elements. They are not very reactive with anybody else because they don't need anything from anybody else to be stable. Yes? The rest of the guys are going to strive towards an 8 in their outer shell. So lithium, this guy over here, how many electrons does lithium have? 3. We're going to put the first 2 in its first energy level, and then the rest are going to go to higher energy level shells. Now, you're going to get a little confused because there are different numbers of orbitals in each energy level. But that's a chemistry thing, and that's for you to figure out in chemistry class. In anatomy class, all you have to remember is 2 and 8. So how many more electrons can I fit in lithium's outer shell? 7 more. And then what would happen? What if lithium got 1 more? If lithium had 1 more? I'd make another what? Another shell. So everything above the first 1 can only have 8. What am I doing in the first one? 2. Everybody else gets 8. So how would I, and they stole my board so I can't even show you on the board. Oh, let's look at these guys. All right, so here's helium. We already met him, yes? How about neon? Where does neon live? On the periodic chart, he's Ne. Where does he live? He lives in 8. Well, what can you tell me right off the bat because you know what 8 means? How many electrons does he have in his outer shell? 8. Somebody also said he's stable. He's also inert. Yes? He's a noble gas. But how many electrons does neon have? 10. Yes? I can't write on this thing. I am so sorry. I'm trying. Huh? I know, but it's doing weird things to me. I just want to write. I don't want to journal or anything like that.